this is number 9 from your text. It was what, page 212?
Yeah.
Okay. So we were being asked to find a quadratic equation, and it says in standard form that fits that. Do we need to write it in standard form right away?
No.
Why not?
We can move it around.
We can convert it if we want. So if we happen to get it in vertex form or factored form, nobody cares. We can get it in a standard form later. So a lot of times I will ignore the directions that the book gives just because I'm going to solve the problem the way I want to solve it, and then I can always put it in whatever pretty way they want in the end. So we need to find a quadratic equation that goes through these 3 points. What can we do to start? Because, I mean, that's intimidating. Just looking at the 3 points. Like, what can we do?
Focus on one.
We could focus on one point. I'm wondering how that would help me. Nope, still confused. What else could we do? Ariana?
Graph points.
Yeah, maybe we want to make a picture of it, right? See what it looks like. Never been asked that question before. So we know -1, +6, so it's somewhere right about in there. We know the 0.14 is on there, so that's somewhere right in there. And then 2,9, oh, that's way high. Should have made more space. But you can see it kind of up at the top there. So I'm wondering, like, what does the picture tell me, if anything? Is there anything that we can see from this? So when we're looking at this, like, what do we know from this picture? What do you feel like you know, if anything? Yeah, Evan?
Never mind.
Nobody knows anything? Emily?
Looks like it's going down.
I know it's hard to see, but I put this other point, like,
Oh.
right up there.
Yeah, I can't see that. Well, I mean, I see a yellow highlight now.
Yeah, so it's like right up at the top there. So does it look like it's still going down?
No, it looks like it's open. Up.
Yeah, so if we were going to sketch it, maybe it does something like this. And it's not perfect, right? But so it looks like it's opening up. So what does that mean for us? Ariana?
So the lead coefficient's going to be positive.
Yeah, that lead coefficient is going to be positive. It's interesting. Can you see anything else? Does that graph help us in any other ways? Okay. Yeah, Max.
The vertex is going to be between 1 and
Yeah, so the vertex is somewhere in here, right? We just don't know exactly where. We could probably start to guess a little bit, but not sure exactly where. But it is in there somewhere. Anything else that we know? Yeah, Claire?
You can kind of see where the y-intercept is.
Yeah, we can kind of see where the y-intercept is. So somewhere in here-ish, right? And that's really kind of going based on my blue graph as being good, which, let's be honest, it's not, right? But kind of get an idea of the y-intercept. It seems like it's at least going to be positive, doesn't it? Most likely.
Yeah.
Evan?
Oh, we know it's translated.
Translated. So you're saying we know it's moved. It's translated. Translated which way?
Left.
Looks like it's translated left and up. Hence the y-intercept is maybe up. So look at all the things that we've brainstormed. Do any of them really give me a solid start for writing an equation here?
Not solid.
Not solid? Should we go for vertex form? No? Why not? We don't know what the vertex is. Like, we don't have a great start for vertex form. What about factored form? Should we go for factored form? Wait, what? Speak louder, people. The video can't hear you. We don't know the x-intercepts. So maybe not factored form. Yeah.
We can put it into a table and try from there.
We could try to put it into a table. Although I guess I'm wondering, like, oh, maybe. That's an interesting thought. So maybe we could try to put it in a table and find the pattern. Although we only have a pair of points, it's going to be tough. We might have to do a lot of filling in. So if I have no solid reason to go for vertex form or factored form, maybe we'll just go straight for standard form. That's a lot of stuff I don't know. What's something we could do right now? So what could we do to start? Logan, you had a thought?
We could create 3 equations using the 3 sets of points that we have.
So we could take one of those points you're saying and plug it in and create an equation for it. I'm wondering, why do you think we want 3 equations?
Because we have 3 unknowns that we have to solve for.
So you're seeing this as a what? What is this reminding you of then? If we have 3 unknowns we want to solve for and we want 3 equations,
System of equations.
maybe it's going to become a system of equations. So let's try to plug that point in. So I'm using 6 as our y value, and then we have a multiplied by negative 1 squared. What's negative 1 squared?
1.
So we have 1a, and then we have negative 1, or b times negative 1,
So negative b.
so negative b, and then we still have the c there. Okay? Kind of makes me think a system. And then Logan said we could plug in the other ones. So then I'm going to get 4 equals, oh, I like this one. See, that 1 value is really nice again. 1 squared times a, 1 times b, or b times 1,
B.
and then plus c.
And that'll cancel out b.
Ooh, it's an interesting thought. Keep those thoughts open too right now. And then we could always do the last one. 9 equals, and then 2 squared is 4, so 4a plus b times 2, or 2b, and then plus c. So Logan is saying this looks like a system. If we want to find a, b, and c, at least we don't have x and y anymore. We plug those all in. 3 equations, 3 unknowns. How might you go, realizing this looks like a system, how might you go about working from here? What might you choose to do next? So where do you think you could start? Where do you think we could start? Nope, not you, Ariana. Ashlyn?
Eliminating the bees.
How would you eliminate the bees? What's that?
They cancel each other out. So you would just.
How? I'm wondering what equations you're using. When you said eliminate the bees, which equations are you using?
The 6 equals a plus negative b plus c, and then the 4 equals a plus b plus c.
So you're saying green and teal.
Yeah.
And if we use the green and the teal, like, how would you work with those equations? How would you eliminate the b?
I was thinking you could add those 2 together.
Okay, cool, I can do that. So we would get 10 equals a plus a is 2a, negative b plus b is 0, c plus c is 2c. Definitely got rid of b. Only two unknowns in that equation. That's kind of nice. What else could I do? Olivia?
So I multiplied the 4 equals by negative 1 to cancel out a and c.
You multiplied the 4 equals by negative 1 to cancel out the a and the c. Oh, so you're saying take the green one and the blue one and subtract them instead, maybe? Is that the same thing as kind of multiplying by negative 1 and then adding them? So I could really, you're saying subtract instead of add? So 6 minus 4 is a minus a, 0, negative b minus b, c minus c. Oh. So you were able to eliminate 2 of them? Which means at this point I know that b is equal
Negative 1.
to negative 1. We already have one of our values. So where might I go next? Realizing we now know the value of B, how could I keep going from here? What's something I could do? Got 1, 2, Emily.
You could try and get like one of A or C by themselves so that like that value equals the equation and then substitute it into a different.
Yeah, so if we could get A or C by themselves, or A or C maybe with B, you're saying, then we could just plug that value in and figure it out. So how could I work with those equations that I have, any of them at all, to get either A or C by itself? And it could always have B in there because we know what B is. Do you have a thought?
You could use the 10 equals 2?
Well, let's see.
No,
It has both of those. So really the goal is maybe can I get rid of A or can I get rid of C, right? If one of them would disappear, I'd just be happy. Claire?
You could subtract the yellow one from the blue one, so you can get rid of C, and you just be left with A and B.
So you're saying work with the purple and the blue
Yeah.
and subtract? Now, when I do this, I'm going to choose actually to subtract upward personally because I like positive numbers. That's the only reason I'm making that choice. It doesn't matter, but that keeps the numbers positive for me. So 9 minus 4 is 5. 4A minus A is 3A. Again, I'm subtracting upwards. 2B minus B and C minus C. Ah, awesome. We got rid of C. So then I could just plug in our B value. So we get 5 equals 3A, subtract 1. And if we solve that, we get A equals 2. And now that I have A and B, I can substitute anywhere I want. We got the blue one, so I might as well use it. I'm going to use that one up at the top. If I plug in A there, I get 10 equals 4 plus 2C. If we solve that, we get C equals 3. Sorry, my equal sign's not coming out great. Which means our equation is y equals 2x squared subtract x, subtract 1x plus 3. Because we were able to do all that. I think as far as creating quadratics goes, this one is probably one of the biggest pains because we didn't know any of the zeros. We didn't know any part of the vertex, right? We had to find 3 different things. And so this is kind of a pain one. Look at our equation. Does it seem to make sense? If so, why? In what ways? Does our equation seem to make sense? So does our equation seem to make sense? And if so, why? You don't have to explain everything, just explain something. Does it seem to make sense? Thoughts? Hands. Come on, people. 1, 2, 3, 4, 5. Good, Ella. Why does it seem to make sense to you?
Because the y-intercept is 3, and it's like around 3, like on the graph, I guess.
So the y-intercept seems to make sense. That's nice. Does anything else seem to make sense about it? The y-intercept is good. Claire?
It's opening up, so you know the lead coefficient is going to be positive.
Yeah, look at that lead coefficient. We said it had to be positive. That fits with our conjecture. You know, that fits with what we saw just from the picture. Anything else? Yeah, those are the 2 I kind of spot as well. So.